Hello and welcome to Blunderbusters. Thank you for stopping by my channel. Today I'd like to talk just briefly about two key techniques that may be helpful to you when you're first learning circuit analysis. Circuit analysis can definitely be a bit challenging at first because there's a lot of information that's kind of coming at you all at one time. You have to learn what type of circuit you have, then you learn to calculate your totals, then we learn that current divides and voltage drops, and we then move into other circuit analysis theorems. But I found that if you're able to follow current first and set the polarities across your components, that really helps to get your work organized, and it gives a lot of clues as to what's going on in your network. So before you begin your analysis, just kind of pay particular attention to what that current is doing. And in these tutorials, I want to make sure we all know as well, I use conventional current flow. Okay, so all my tutorials will have current flowing out of the positive of our source and returning back to our negative. Okay, so just want to clarify that point. But when we have a series circuit, current stays the same. Okay, and if we watch the current, we look at that current, well, it makes sense. So our first circuit here is a series circuit. And if we note at this circuit, well, our current has no room for division. It just remains the same. So our I total is going to be flowing throughout that entire circuit. And we're going to be able to use that I total when finding various unknowns, okay? So, but when we move to our parallel network here, that looks a little different, right? It's like, okay, we see at this point, at this node, and I have it denoted with a black circle here, but at that node, current will then divide. So those electrons have one of two branches to flow through, okay? And then the I total is going to regroup here at our node along here at the bottom, again denoted with our black dot, and then it returns back to our source, okay? So we see here, it's like, okay, well, we have current division. Certainly looks different from our series circuit. So we know, okay, current's dividing here, right? So we know that when we're going to be using our current values, we know we can't use I total when calculating unknowns across this branch because our I total is not flowing here, okay? I total is flowing at this point, but then I total divides, and it has to because it has two branches that it's able to divide through. So we have I total that it's going to divide through those two branches, then return back, and then I total returns back to the source, okay? But now we can no longer use I total in some of our calculations with this parallel network, okay? So we need to be mindful of that. Right, and lastly, we have a series parallel network here. What we mean by this is we have, well, our I total is going to flow through this part of the circuit and this resistor. Okay, so our entire current will flow through. However, right at this node again, or our black dot, we're going to see a different values of current because current is now dividing. So when I'm being tasked to find perhaps an unknown, a voltage drop, or current value, we need to be careful. What we want to do is observe that current. So before I start my analysis, if I'm kind of paying attention to what my current's doing, it's going to give us a lot of helpful hints. So I total will be flowing through this resistor, but it's not going to be flowing through these two resistors because it divided at that node. So I need to be careful what I am going to be using when I'm finding my unknowns. And that's why I like to tell students to definitely watch our current. Figure out what the current's doing first, kind of get a gauge for that. Note where that I total is flowing through, where it's dividing. So we're careful when we're finding our unknowns, okay? So again, just following this current first very, very helpful. First of all, it's going to help us to determine what type of circuit we have. Do we have current staying the same, or do we have current dividing? And it's also going to give us helpful hints when we're being tasked to find unknowns. Okay, so I like to say before we begin our analysis, please follow current first. Okay, and just kind of get a feel for what's going on with that current. That's step number one. And step number two is definitely setting our polarities across our components. And we use current direction to do that, okay? So what I like to do is anytime I see and I note my current flow, I then say, okay, when current flows into the resistor or into the component, we're going to give it a plus. When it leaves the resistor or component, we're going to give it a negative, okay? So I gave my positive and negatives, I set those polarities, okay, across all my components. It may not seem very clear now when we're first looking at circuit analysis work, but I'll tell you, as you're progressing with your analysis and your studies, determining that polarity will be very helpful, particularly with certain theorems like our superposition and loop equations. And again, we'll get to those things later in our Blunderbuster tutorials. But for now, when we're first learning circuit analysis, I like to again say two things. Follow the current, get a feel for what that current's doing, where we're seeing I total, where we're seeing current division. Okay, that's number one. And then number two is setting the polarities. Okay, those are just great tools to get our work organized and make sure we're determining what's going on, what type of circuit we have, and what that I total is doing, what that I value will be as we're needing to find unknowns. So again, those are maybe two helpful techniques that may be helpful to you when you're first starting circuit analysis work. And I have to tell you, circuit analysis is probably my favorite. I really enjoy circuit analysis. It's the best. I love it, and I'm really looking forward to developing additional tutorials to help you along your journey in your circuit analysis work. So thank you for watching. Have a great rest of your day, and looking forward to seeing you on many more Blunderbuster tutorials. Bye.